Hey boys and girls, we have returned and we're going to work on testing the PTC heating element under stress-related conditions today. We're going to power it up and run it for a few minutes, and then we're going to kill the blower motor and see what happens in relation to the saturation point of the current. Let's see if it actually is current limiting like they say it is, and if so, what temperature we get on it when the heating elements become so resistive they pass no current. Alright, let's get some baselines. I have a thermocouple plugged in the front. It's just kind of laying there. We may have to adjust it, and it's showing 72 degrees. And then I have a meat thermometer laying on top of the composite plasticky fiberglass looking housing that the heating element's actually in. So that's actually not metal or anything, it's a composite material. I have it taped down with a little metal foil, so hopefully it'll get a little heat transfer. And it's showing 78 degrees. So, you know, we have a little bit of disparity between the two, but we have a baseline to work with. So that's where we're going to start. Now let's just fire it up and come over here and we'll power it up, and it's preset on 86 and it's already kind of nice in the room, so it'll take a little bit. And we'll walk back around, and I have the other camera set here and it's doing the job, and we can see it's starting out as a nice bit of amperage, and it's working its way up, slowly scaling itself up. And I'm only pulling one line off of the common this time, so we're measuring both heating strips and the blower motor up here all at the same time. So jump to 11, now it's back down to 10, it's dropping a little bit. And our temperatures are coming up pretty quick. We have 150 degrees on the output and 97 degrees already on this bit here. So you can feel it warming up there. So we're going to let that run a few minutes. Let's make sure the element's behaving. I have it in there and it is just hanging free. It's not touching the copper back piece or anything. It's just enjoying the heat. We'll let this run a few minutes and see what kind of temperatures we have and where it levels off at. And I'll edit the video for time as we go to make it a little more pleasant. So we're at 164 here. The actual composite material is up to 110. And we're just under 10 amps. So the amperage has dropped down some. When we get ready to cut the fan to see what happens, do the smoke test if you will, I have the back panel pulled off and a pair of needle nose pliers. And I will very delicately reach in here and I will just pull the fan terminal right off and kill the fan. And then it will get really interesting really fast. So we're at 168 degrees currently over here, and 120, and it is, let's say, 624. So we're going to kind of watch that, and we'll say 10 amps. We'll just call that 10 amps. And when we see it, everything level off temperature wise, then that's when we'll have a little bit of fun. Up to 170 degrees, and I'm going to enjoy this, I think. 125, or it's risen to 125. So actually reach up carefully up here and put your finger on it, and you can feel it warming up. Now the sheet metal is hot, so let's make some notes. Where are we at here? 172 degrees output, and 100, and we'll call it 127, and at 9.9 amps, and it is 627. So 3 minutes have passed and it seems to be leveling off. The output temperature seems fairly steady, 172, 173. having not risen much from the original 168. And we still have a little higher temperature rating here, 127. It was 128 a second ago, so it's changing a little bit. But the current is still at 9.9. So I think we're at probably a level point here. Let's have a little bit of fun with it. And my fire extinguisher is right over there. So now that I think it's leveled off a little bit, and let us pull the fan carefully. Reach in here, make sure it's the right one. It says fan. Fan is now pulled. You will also note that I didn't mark earlier, or maybe I did note, I have the safety bypassed for this test so that it will not cut the power. Let's see what happens. The current has dropped. The current has dropped to, wow, it is cutting it. The current has dropped down to 1.4. Without the flow going through it, the current is limiting. It is, wow, that's amazing. The temperature is 120 and 167, but the current is down to 1 amp and dropping. That's pretty amazing. So what they're saying is true. Not passing any airflow through it to distribute the heat, and the PTC elements are definitely not passing current. That's amazing. So 0.91 amps. It is very, very, very resistive. So I don't know what the actual internal temperature on that is of the actual stones. Now I'm shooting that here and I'm getting 126, 125. Now this is up 135. So the actual temperature here has gone up. You'll notice the temperature over here has dropped a little bit, but the temperature is now up to 140. Sorry, let me reset this over here. The temperature is up to 140 degrees on the fiberglass or PVC plastic material here, and 147. And the current draw is down to 0.86 of an amp, where it was 10 amps when we started. And so we're down to 0.84. It clamped it down nicely, and the temperature is still rising at 171. And we have a nice high temperature here, 160-ish. So it's leveled off pretty good. It's holding the temperature at 162 there, 175 here. So let's make notes. We're at 164. This is fan off, 164. And 178. And 0.83 amps. And this is now 632. So it does what it says. I mean, you can definitely smell it, and the temperature is 170, 180 on the actual heating piece here. Ooh, oh yeah, that is hot. That is burning hot to the touch. Definitely burning hot to the touch, so you can smell it. But the current is dropped again. It's down to 0.75 as opposed to what it was a while ago. And the temperature over here has dropped to 153, and this is up to 185. So it's kind of a sniffing, smell good drama. So the technical safety is correct. It does amp clamp it, if you will. It does cut the current in a safety manner and limit it once it reaches a certain temperature. Now, what the temperature that these particular stones, these PTC stones in here, are supposed to reach when they max out, I don't know on this particular unit. But that's the question. And obviously they designed it so that, should have designed it so that the stones are far enough away from the material that it won't melt or catch the material on fire. Alright, we are at 160. Let's mark that, 160. It's dropped some more. This has gone up to 199 degrees, which was originally 120 degrees when the blower was running. We'll call it 200 now, and still climbing. And we're down to 0.75 of an amp at 634. Okay, very good. Well, we've made our point, so to speak, and it hasn't technically smoked. Well, it has. You can kind of smell it. It's not catching on fire. I don't know what the ignition temperature is of this material, but I would assume it's higher than the 200 degrees that we're shooting it at here. It's just warming it up enough to smell good, really good. So, but very interesting. So, like, once again, just a recap, the design is that the stones are designed, the PTC heating element is designed so that the higher the temperature, they design, say, a stone for, say, 500 degrees. The closer it gets to 500 degrees, the higher the resistance gets, which means the less current passes through it. And we're seeing that very clearly here. At the temperature is 209 here, 164, and 0.74. We'll do our last readings here, 0.74. The amps have not dropped a whole bunch. The temperature has definitely gone up. We're at 211. And 163 over here on the output. Just the heat rising through the chamber over here, through the column. So, and this is continuing to rise, and we could go on for quite a while. But that is a great sampling, and I'm not going to smoke it because I'd really like to use the unit. But it's a pretty good example of how it works, and we've proven that what they say on the amp clamping works, or the resistive elements work well on it. So pretty neat. I think I'd rather have one of these than heat strip elements or even infrared lights. It's just a pretty nifty design. So we may have reached an optimal range for it at 0.73 amps, and we're going to call it, let's just call it 214. Encircle that, and 162, and 0.77 amps. A little bit there. Of course, the air conditioner's kicked on too, so 215, 216. Beautiful. Alright, well, thanks very much. I appreciate you guys hanging out, and I'll post this one pretty quick. This will be like a 15-minute video, hopefully. And let me fire the blower back up, and we'll have a bit of a good time here. This was rather informative and fun. Alright, there we go. And I guess we could nurse it down. Oh, the amps, bam, shot right up, straight away. Straight up to 9, and the temperature rise on that is already up to 180, and this is dropping fairly quick, 210, 29, 28, so very good. Picking right up where we left off, and golly, so 180, so it's going to have to distribute some of that heat. It was originally 168 when we had it maxed out originally, but 190 and dropping, so it's dissipating the huge amount of heat that we had built up in here, 200 plus, and leveling off nicely. So beautiful. Thanks again for spending time with me, and I hope you enjoyed this informative video. This is for technicians only, boys and girls. Do not bypass safeties. As I was telling you, you can still smell the heat in there. The plastic is not melting yet, and I would assume it's not if they designed it properly, but that doesn't mean anything. But safety first. Don't bypass that. It's just for our test fun here. This is for technicians only. So if technicians want to do this, great. Homeowners, don't do this. Do not do this at home. I feel like Mythbusters. All right, beautiful. And with that, we'll shut it off at 151 degrees and 175. Thanks for watching, gang. All right, get on track here and track. Okay, a small addendum. You will notice the high temperatures that we had on the output with and without the blower on. The limit switch seems to be, on this particular brand model, seems to be a failing point a lot of people complain about when I was looking around, especially on especially on Amazon. Let's try that again. Cut. The limit switch seems to be a big complaint point. Failure. It won't come on and stay on, or it comes on for 3 minutes and shuts off, etc., etc., which to me indicates the limit switch, even though some customers had them told that it was the board or something else. Well, the limit switch is 80 degrees Celsius, which is 176 degrees Fahrenheit. Even when we were running at optimum temperature with the blower on and it was nice and fairly comfortable in the room, by about 73 degrees in the room, 74, 75, somewhere in there, it was running pretty close to the top end. I mean, the limit's 176 and it was putting out 165, 160 degree, 67 degree air. So that's kind of pushing the limit switch to a wear point pretty regularly. You would think they'd set it a little bit higher, maybe, I don't know, a little more disparity in the actual output temperature as opposed to where the flip point on the device actually is. So I'm thinking that might be why the things were failing, is the tolerances on those little snap discs are, they're not so tight that you would want the temperature break to be that close together. So anyway, just an afterthought. Don't know that they fixed that problem on newer units, or I'd be curious to lay my hands on a newer unit and see if they change the output temperature, or if they change the snap disk temperature, or what. So kind of curious to see. Anyway, just thought I would update you guys on that. And with that, apologies for the really bad audio tracking. It's kind of fun trying to piece two pieces of video together and time it when you're in a hurry. Alright, take care, bye. Thanks, and see y'all later.